So good morning everyone and welcome to the lecture. This is lecture number 12 and we are dealing with rotation. Plane motion, to be very precise, we are dealing with plane motion and what we discussed in the last class. In the last class, I think we were discussing how any motion can be taken as a combination of rotational motion about the center of mass and the translational motion of center of mass, how we can find out the velocities of various points of a body in plane motion. It may be in rotation as well as translation, how we can find out the velocity, how we can find out the accelerations, centripetal, tangential, and then we are also seeing how we can find out the what kinetic energy and angular momentum of the body. Do we remember this, or we remember this? And then we saw how we can find out or convert a pure rotational motion into a combination of rotation plus translation. Do we understand this? Yes or no? Do we understand this? Yes or no? Do we understand this? Yes or no? Is the phone mic working? Not working.
Sir, am I audible?
Yes, you're audible. Do we understand this?
Yes, sir.
How we had found out the various things here. Now, as I think I ended the class saying that since we can convert even pure rotational motion into a combination of rotation and translation of the center of mass, in similar way I can convert any combined motion or any plane motion into a pure rotation at any point in time. Do we understand this? That means any motion, whether it is a combination of translation or rotation, I can convert it into pure rotation. Any motion which is a combination of translation and rotation can now be converted into pure rotation. Do we understand this? That concept is what we are going to study today. The concept of instantaneous center of rotation or the concept of instantaneous axis of rotation. Instantaneous center of rotation, or you can also call it instantaneous axis of rotation. ICR, instantaneous center of rotation or instantaneous axis of rotation. So what things you must understand about this? At any point in time, a rigid body can be considered in pure rotation about a point or an axis which passes through that point. This point or this axis is known as the instantaneous center of rotation or instantaneous axis of rotation. Do we understand this?
Yes, sir.
Now, any general motion of a body can be considered as a combination of translation of the center of mass and rotation about the center of mass. Now, whenever we are taking body as moving in pure rotation, as you can see what we had done here. In this question, what we had done for this body was actually in pure rotation with an angular velocity omega, but we broke it into two motion. One was rotation about the center of mass and the other was translation of center of mass. Now what thing we have seen is here that the two angular velocities that we had taken, they were same. So that is the concept that we must remember, that whenever we are converting this plane motion into pure rotation motion, the angular velocity about that axis of rotation will be same as the angular velocity with which that body is actually rotating about its center of mass. Do we understand this? So that is the next point that you must remember, that the angular velocity omega about this IAR or ICR is same as the omega about the center of mass. Do we understand this?
Yes, sir.
Again, this instantaneous center of rotation is again a point through which your IAR passes. Do we understand this?
Yes, sir.
And it is perpendicular to the plane and all that. Remember, this ICR is a point which has zero velocity. It is not moving. As you can see, this is a point with zero velocity. As you can see here also, when we had taken the rotation, this point A, this A was the ICR. This point A had zero velocity. Do we understand this?
Yes.
Yes or no? Now remember, this concept of ICAR or ICR is an instantaneous concept. That means your ICR or IAR will keep on changing with time. ICR or IAR, these are instantaneous center and instantaneous axis. So these will keep on changing with time. Do we understand this? So at any moment, whatever is its axis, that is known as instantaneous axis. At any other moment, the axis would change. Do we understand this? It is just like instantaneous velocity or instantaneous acceleration. It is defined at any instant. After that instant, it will change. Do we understand this?
Yes.
Okay, note it down.
Done, sir.
Everyone got this?
Sir.
Yes or no?
Yes.
Now, the question comes, how are you going to locate this instantaneous center or instantaneous axis of rotation? How are you going to rotate this instantaneous center or instantaneous axis of rotation? Yes, tell me. How are you going to rotate? How are you going to locate them? How are you going to locate? Yes. So we can understand this taking different cases. For example, the first case, you know the angular velocity omega with which the body is rotating, and you also know the velocity of the center of mass of the body. Then you can locate your instantaneous axis or instantaneous center of rotation. How are you going to locate it? How are you going to locate it? Let us say this is your rigid body. This is your center of mass, C. Now let us say the body is rotating like this with an angular velocity omega. The body is rotating like this with an angular velocity omega, and let us say the velocity of center of mass is like this. How will you locate? How will you locate? Where is your center of instantaneous center of rotation? How will you locate? How will you locate your instantaneous center of rotation? You will draw a perpendicular like this. The velocity of center of mass should be, remember, this body is going to be taken as body which is in pure rotation. So you must be able to get the velocity of center of mass from the center of rotation. So your velocity of center of mass must be perpendicular to the line on which the center of rotation lies. So this is ICR. This is somewhere your ICR will lie, and the distance from the center of mass to your instantaneous axis of rotation, let us say, is R. Then by common sense or logic, you should be able to tell me what is the value of this R. This is a purely geometrical construction. Omega is known. Remember, it is going to move with the same angular velocity. So the angular velocity about this point will also be equal to omega. And you must be able to find out the velocity of any point from here. You need to find out the velocity of center of mass also from this point. So what will be the value of this R? The value of this R will simply become velocity of center of mass divided by omega. And this must be perpendicular. Once you know the instantaneous center of rotation, an axis which passes through this instantaneous center of rotation perpendicular to the plane of the motion of the body, that will be your instantaneous axis of rotation. Do we understand how I have done this?
Yes, sir.
What, sir? Now, if I have to find out the velocity of any other point, if I take any other point, let us say this is point A, what will be the velocity of this point A? How will you find out? This point A is some point on the body. How will you find out the velocity of this point? At this instant, remember, at some other instant it will be different. At this instant, how will you find out the velocity of this point? You will join this point with the instantaneous center of rotation. Remember, this body is in pure rotation now. The velocity of this point has to be perpendicular to this line because it is in pure rotation
Yes, sir.
and it is rotating with an angular velocity omega. So if I call this distance as the distance of A with respect to your O, which is your instantaneous center of rotation, and this will be the velocity. So I can write velocity of this point A will be equal to omega multiplied by distance of A from O. That is how you can find out. Once you understand or locate your instantaneous center of rotation, you will be able to find out what?
Velocity.
Huh?
Velocity.
Velocity of any point on that rigid body. Do you understand this, or this has gone above our head saying bye bye, bye bye, sir, bye bye, bye bye, bye bye?
We got it, sir.
I'll give you 2 minutes to note it down.
None, sir.
Done, sir, because the next question you have to do, sir. Then don't say, sir, that we understand it or not understand it, sir. You do it very quickly, that's a very good sign, but after doing it so quickly, you must also solve this question. So here is the question coming up. I'm very impressed with your speed. And I hope that you're able to solve this question with the same speed. Even if not with the same speed, even if you're able to solve this, it would be a good thing to. This is, let us say, a disk of radius r. The center is C and the radius is r. This disk is rotating with an angular velocity v by r, and it is moving forward with a velocity v. The first question that you have to do is to find out what, my dear friends? What? You have to find out the instantaneous center of rotation of this body. ICR, you have to locate. Where is that? You have 2 minutes to do it. Yes, bacha. Anyone there with an answer? Are we still thinking? Yes, I can hear discussions, but I don't hear an answer. Huh?
It will be top of the disk or bottom of the disk, sir.
No, you can't give two answers. Top of the disk or bottom of the disk, no. Cannot be at 2 points. It has to be at 1 point. What is that point? So you have to locate it. How are you going to locate it? Since the velocity of center of mass is like this, it has to be perpendicular. So it must lie somewhere on this line,
Yes, sir.
somewhere on this line. And the distance of this would be given by the distance of the or the radius of that or the distance will be given by v divided by omega, and omega is given as v divided by v by r.
Yes, sir.
So it must be at a distance r from this. Now there are only 2 points at a distance r from this, point A and point B. Which is that point? A or B?
Yes.
Why A, sir? It is point A. Remember, it has to rotate with the same angular velocity v by r. When it rotates like this, then only the velocity of the center of mass will go in this direction, because it rotates like this. If it starts to rotate from point B like this, from point B, if you rotate it like this, the velocity of center of mass will go backwards, and that is not possible. Therefore, point B is not possible. Do we understand this?
Yes, sir.
So the velocity, the instantaneous center of rotation is the point of contact. Do we understand this?
Yes, sir.
This is known as pure rolling. This is the case of something which is known as pure rolling.
Sure.
Pure rolling. Your ICR or instantaneous center of rotation is the point of contact. Is the point of contact. Do we understand it? Or is it gone about saying bye bye, bye bye, bye bye, bye bye?
We understand, sir.
This is the point of contact. Now, we have already seen how to find out the velocity of this point A. It is rotating with an angular velocity and it is also moving ahead. If you find out the velocity of this point A, how much will be the velocity of this point A, obviously with respect to ground? How much will you get this velocity of A with respect to ground, which is also your instantaneous center of rotation? What is this velocity of point A with respect to ground?
Velocity of point A with respect to C plus
I know that. You know it. You have to tell me the value. Everything is given to you. No one knows how to find out the point velocity of point A?
1 minute.
You forget things. Just in the last class, I told you we did all this. Now it has gone down the drain. And right now it will be in some sewage plant getting treated. Everything gets flushed down the drain. So sad. Anyways, I will have to do my job, and I can't give you infinite time to find out this velocity of this point A with respect to ground has to be 0. We just had written it here also. Same thing has to be told to you in different ways. I don't know where our brains are. We just write and we don't really understand. I don't know where we keep our brain. We keep it in a deep freezer and then we come to the class. Put the brain in a deep freezer. Let us chill out. Why do we need brain in a class? Why do we need a bloody brain in a class? Right? We don't need a bloody brain. That's no use. Brain is of no use. Keep it in a deep freezer. It will chill. We'll go in the class and chill without the brain. Maybe we could go back. We'll put the brain inside and do things. So the velocity of this point is actually 0. It comes by 0 by this pure rolling thing. The relation between omega and v is such that the velocity of point A becomes 0. It becomes your ICAR. It becomes your instantaneous center of rotation. Anyways, I must keep my disappointment to myself, and I can't be more disappointed because I have to somehow complete your course. I know even after completing your course, it will be of no use. Because if you can't remember what we had done in the previous class, what will you remember 6 months now, in April or May, when your exam is going to happen? You will be completely zeros. But then I have to do my job at least. Anyways, having said that, now we can find out the velocity of any point once we understand that point A is the instantaneous center of rotation. Now, can you tell me? Well, I don't expect that you will know that because we have forgotten everything that we have done. But still, hoping against hope. Can you tell me what will be the velocity of point B? I can find this velocity of point B obviously with respect to ground by 2 ways. I know that you don't know the 2 ways because you would have forgotten everything that I have told you. But still, hoping against hope. Hope floats, faith survives. Even if there is Kayamat, faith will still be surviving, at least mine. So, by any chance, can you tell me what is the velocity of point B with respect to ground? Any chance? Is it possible for you to tell me what is the velocity of B with respect to ground? I'll give you 2 minutes to remember God, remember your prayers. Hey Bhagwan yaad dila. Hey Bhagwan yaad dila. 2 minutes. Say your prayers.
2VI, sir.
Yes, what is the answer?
2VI. 2VI cap.
See, God exists. See, God sees that, we are working so hard, so he exists. That, you know it. Yes, it is 2 times VI. You can do it by the concept of velocity of B with respect to C plus velocity of C with respect to ground. You can do it in this way. We have already done it in this way in the previous class. But now I know the angular velocity is V by R and this point is in pure rotation. So if the angular velocity is like this point has to move forward. And what will be the velocity of this point? The angular velocity is v by r. And I just multiply it by the distance of this point because it is perpendicular. I multiply it by 2r and I get the answer as 2v. I get the magnitude. I can also now find out the velocity of this point C. What will be the velocity of this point C? What will be the velocity of this point C with respect to ground? Yes. No answers? So how do I get this? I join this point to the center of rotation. It is rotating. So its velocity must be here like this. This will be the velocity of point C. The length of this line, my dear friends, is how much? This is a right angle triangle. So it is root 2 times R. So I can straight away write it as root 2 into V. And now I can resolve this into two components. One is the component along x. So when you resolve it along x, you will get the velocity of center of mass. And one is the component along y. That will give you the value of omega of the center of mass. That is how we found it out. In the first case, now I am straight away getting the magnitude using the concept of instantaneous center of rotation. Do we understand this, or this has gone? Everything goes above our head. Even if it does not go above our head, we don't remember it. So it is just like going above our head. But is there any chance that you understand this?
Yes, sir.
Thank God. God exists. I always start believing that God is no longer there. But sometimes I remember that God does exist. God does exist. Almighty exists. Now, to understand this concept that how beautiful this is. I know you will forget it tomorrow, but still, it's my duty to tell you. I'll do my duty and I'll keep all these notes with me. And when the exam come, I will take a special class and I'll tell you each and every question which came from which part of my lecture. Each and everything I'll tell you. And I'm just doing it for myself. And I broadcast it live on YouTube with hundreds and thousands of hopefully viewers watching it so that I can tell you how great I am. And I discuss every question in the class. But still my student could not do it because they could not remember because they were Gajnis. Comes the next one. Let us find out the kinetic energy of this body. Now I can find out the kinetic energy of this body in two ways. Forget about two ways. Can you find out the kinetic energy in any way? I know you will not remember the two ways, but can you find out the kinetic energy in any way that you remember? You would have forgotten that. I know that. Can you find out the kinetic energy of this body? That is just to get the concept deep inside your body. Even if you try to forget it, I want to forget it. It will come from somewhere. Whoosh. Yes. What is the kinetic energy of this body? Hui, 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 hui. This body is actually rotating about the center of mass. Hui, hui, hui. So for that, I have to tell you the mass of this body. The mass of this body is m. It is a disk. This. No, let me not make it. Let me make it ring because it's not looking like a disk because it is not borrowed. So let me call it as a ring. It is a ring of mass m. Can you tell me this kinetic energy of this gentleman? I can do it in two ways, but I know you will not remember those two ways. At least one way, one way, my way, highway, your way, highway. So I've given you enough time. If you can't do it, it's of no use. So I can do it as this. I can find out the kinetic energy of translation, and then I can find the kinetic energy of rotation of this body.
Sir,
Yes.
mv square.
Okay, let's see. I don't remember it. I will have to calculate it. So I'll just do it here. So to find out the transitional kinetic energy, I will do half mv square. Then to find out the rotational kinetic energy, it is half into I. Remember, it is ICOM. So it is half mr square. Omega is v by r square. So I end up with the same answer, mv square. That is the kinetic energy of this body. Do we understand this?
Yes, sir.
Thank God. See, God exists. I don't know why I start believing that God does not exist. This is one way of doing it. Is there any other way of doing it? Huh?
About point A, sir.
See, God exists. I can either find out this way or I can just do it the other way around. Why should I take transition and rotation when I can take it as complete rotation? We. So I can now find out this as pure rotation. Does not have any transitional kinetic energy because I am not taking it as a pure rotation about the point A. So now half into I. Now remember, this I has to be the moment of inertia about the point A. Do we understand this? Yeah? So moment of inertia about the point A will be the moment of inertia about the center of mass plus mr square. Yes or no? So it is, it is half into 2mr square. Do we understand this?
Yes, sir.
Into v by r ka whole square. And you see, you end up with the same answer because both these motions are exactly same physically by physics. One more point I need to make at this point. Can you find out the angular momentum about the point O? Oh, not O. That lowest point A. Angular momentum about the lowest point A. Angular momentum, so that we understand that everything that we are doing, whether we do it that way or we do it this way, it's same. The only thing we have to understand is it clear in our heads? If it is clear in our heads, it will be clear in our minds. And we shall overcome. We shall overcome. We shall overcome one day. And you have to give the answer in vector form. Your x-axis is like this, your y-axis is like this, and your z-axis is coming out. Ding 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 ding. So, how do we find out the angular momentum about the point A? So you can do it by this method. You can find out the what?
Minus 2 mvr k cap.
You can find out the angular what I call orbital angular momentum. Plus, I can call it the spin angular momentum.
Yes, sir.
So to find out the orbital angular momentum, this is the momentum is mv multiplied by r, and it is along minus z axis. Yes or no? So it is minus m. Where is m? Minus m v r k, and then you can find out the spin moment. I omega m r square into omega is v by r, and this momentum is also along, this angular momentum is also along minus k. Yes or no? So you will get the answer as minus 2 mvrk. Do we understand this?
Yes, sir.
Or I could do this in this way. Straight away find out the angular momentum about point A by taking as a pure rotation about the point A. And in that case, it is only the spin angular momentum, the orbital part goes away. So it's only the spin momentum. What is the moment of inertia? mr square plus mr square. 2 mr square into omega is v by r, and this omega is also along minus k. So you end up with the same result. You understand this? Yes or no?
Yes, sir.
Pakka, sir?
Akka, sir.
Chalo. I hope that you have understood this. I'll just give you, we have done everything in this question just for you because this was pure rolling and these things are going to come sometime, many times. That is why I done the question in great detail. I will move on to the next question. And I hope that you are able to give me satisfactory reply for this one so that I can move ahead in life. Shall we move on to the next question? Yes or no? Huh?
Yes, sir.
Huh. So this is a rod of mass m and length L, and it is rotating about its center of mass with an angular velocity v by 2L, and the center of mass is moving with a velocity v. I'm not going to ask you many questions because once you understand one concept, you should be able to find out the rest of the things. Can you calculate can you find out what is the instantaneous center of rotation? Where is that? And can you tell me the kinetic energy of this rod? Whatever way you want to tell me, you can tell me. Your time begins now. Yes, bacha.
Mm.
Anyone with any answer?
1 minute, sir.
1 minute, sir. 1 minute. 1 minute. 1 minute. 1 minute. 1 minute. 1 minute. Okay. Yes. Anyone has an answer?
Sir,
Yes.
kinetic energy is 49 mv square by 96.
Okay, I don't know the kinetic energy, but let me first find out the instantaneous center of rotation. Velocity v is like this of the center of mass, so it should be perpendicular to this. So it must lie somewhere on this line. It can lie above the center of mass or below the center of mass. Where will it lie? Above the center of mass or below the center of mass?
Below the center of
Below the center of mass. Let me call this point as O. And remember, it is going to rotate like this with V by 2L. What will be the distance of this point, center of mass, from this O?
12.
Wow, shabash. This will be equal to 2L. Do we understand this? Now you can find out the kinetic energy by any ways. You can find it out by translational rotation, or you can find it out by pure rotation. I will just use the translational part. So how I am going to find out the kinetic energy? I am going to find out half mv square. So you have to look for the easiest way to do it. This easiest way right now looks half mv square plus half I omega square. Why would I find out that point and this? You have to understand the question, what it is asked and how you can do it quickly. So half I omega square plus half mv square plus half I. What is the moment of inertia of this rod? ml square by 3. Yes or no? ml square by 12. Yes, thanks for correction. ml square by 12. V by 2L ka whole square. You add these two terms and you will end up with your answer. Do we understand this? Yes or no? No, yes. Huh?
Yes, sir.
Okay. Now, let us move on to the second case. Case number 2. How you can find out the and center of mass, velocity of 2 points are given. And these velocities are intersecting velocities. What do I mean by intersecting velocities? So we can take an example like this. This is, let us say, my rigid body. I have a point A whose velocity with respect to ground is VA. Then I have a point B which has a velocity VB. Now, how I am going to get the instantaneous center of rotation in this case? So what I am going to do is I am going to draw a perpendicular to this line. Do you understand? Because this velocity has to be perpendicular. Yes or no?
Yes, sir.
Then I will draw a perpendicular to this velocity. This is perpendicular. This is perpendicular. they are going to intersect at some point. That point becomes your instantaneous center of rotation. Do we understand this? Yes or no? It has gone above everything. Bye bye. Bye bye. Bye bye. Huh?
We understand, sir.
Okay, good. This distance, let me call it as distance of point B, RB, from the instantaneous center of rotation. This distance you can call it as RA. Now remember, this angular velocity omega will be equal to magnitude of VA divided by RA. That should be equal to magnitude of VB divided by RB. Do we understand this? Yes or no? Because VA will be equal to omega into RA and VB will be equal to omega into RB. Everyone understand this? Yes or no? No or yes?
Yes, sir.
Now remember here omega, the angular velocity about the center of mass is not known. The velocity of center of mass is not known. What is known is the velocities of 2 points. Let us see how we can use this in questions and what type of questions can come. Remember, these questions may look tough, but I can't help it. I mean, they are what they are, and I can't help it. Okay, so now let me frame this question for you. Normally, I do this question before also, but because of time constraint, I could only. Oh, I have this. I have this. I have this. So let me make this from here only. Let me just take this off. Okay. So I'll give you this question. Now the question is like this. The diagram was actually not a part of question, but that is the only thing that I got. This is a rod which is kept with in contact with two walls. One is the vertical wall and one is the floor. Do we see this? Normally, how the question is framed that you are given the velocity of any one of the ends. Here in this case, the velocity of the end A is given to you. The velocity of end A is like this, and the velocity is given as VA, or you can simply call it as V. Now, if this rod, this end goes here like this, what will be the velocity of the top end? Will it go down or will it go up?
Down.
It cannot go up, right? Because it is a rigid rod, right? It has to go down. Yes or no?
Yes, sir.
The question is, this theta angle is given to you. So what are the two things that are given to you? The velocity of the rod, now velocity of point A is given to you, the angle theta is given to you, and in most cases probably the length of this rod L, and let us say the mass of this rod is also given to you, so I can make this question bigger. Length L and the mass of this rod is given to you, theta is given to you, velocity of point A is given to you. What is basically asked in this question is the subse simple question, the most basic one is what is the velocity of point B. So I'll make all the questions, and if you can solve all, that means you know everything that you need to know about rotation. Remember, no one understands rotation. So velocity of point A is given to you. You have to find the velocity of point B. That is the most general question that is asked. I can also ask where is the ICR. I can also ask what is the omega about the ICR. I can also ask what's the velocity of center of mass. And the most difficult question, what is the kinetic energy of this rod? Best of luck. What is known to you is the velocity of point A. You can call it as V or you can call it as V. Let's not call it as VA. Let us call it as simply V. The velocity of point A is given as V. These are the things that are asked. God bless you. Take your time. You can give this answer. That means we are on the right track. Even if you don't give the answer, it's okay. Don't worry about it. This is not a simple question. One part of it may be simple, but all the parts are not simple. Don't worry if you don't get it completely. It's absolutely normal. No one understands rotation, remember. Just but anything that looks like an answer.
1 minute, sir. VB ante. Sir,
Yes.
VB is VA by tan theta, sir.
Good. I think that looks good. How did you get VB? Just like that, sir. Okay, I'll give you time.
You gave above one formula, no, sir. From that we derive.
Okay, good. Very good. You surprise me sometimes. Good. Then the rest of the questions would be simple. If you got one, you should be able to get the answer. I'll give you 1 minute. If you can get all the answers on your own, that is really great. Yes, shall I do it? So basically, what we are going to do here, is basically simple things. And what are those simple things? We will draw perpendiculars to the 2 point. Do we see these perpendiculars here? This is the perpendicular drawn to this point, and this is the perpendicular drawn to this point. So you can locate the ICR. Yes or no?
Yes, sir.
This angle is theta, so this angle will also be theta. So this distance will become L cos theta. Yes or no?
Yes, sir.
And this distance will become L sin theta. Yes or no?
Yes, sir.
So now you know the location of the center of mass as well. Yes or no? No, not the center of mass. The location of the instantaneous axis of instantaneous center of rotation. So you can say the velocity of point B. If the velocity of point B is VB, you can write VB divided by L cos theta, the angular velocity omega, that will be equal to velocity of point A divided by L sin theta. Yes or no? And that will be equal to omega. So velocity of point B will be V divided by tan theta. And V divided by tan theta
By L cos.
is VB, and that will be, from here they can also find out the omega. Omega is V divided by L sin theta. So what all things are known? We have calculated this, we have calculated this, we have also calculated this. Yes or no?
Yes, sir.
Three things already done. Just have to find the velocity of center of mass. Can anyone tell me what is the velocity of center of mass? Huh? How do I get the velocity of the center of mass? Hmm?
Where is it? Under root VA square plus VB square.
No, it is not.
Okay.
How do I get it? I know omega.
Hmm.
How do I get it? One way of finding it out is if you know the center of mass is at L by 2. The center of mass is at L by 2. You can join this line by the center of mass, and the velocity of center of mass would be perpendicular to this line. So it would be going like this. It would be going somewhere like this, perpendicular to this line, which is not looking perpendicular to this line. So let me draw it like this. It would be perpendicular to this line somewhere like this. You just have to find out how much is the length of that line. And how will you find out the length of that line? The length of this line. This is pure maths. It's got nothing to do with physics. This is pure maths. How will you find out the length of this line? How will you find out the length of this line? You know the length of this part. If I call this point as O, oops. If I call this point as O, you know the length of this is L by 2. You know the length of this is L by 2. Yes. So that is one way of finding it out. That is pure maths. I'll leave that to you. I'll show you the other way of doing it. Now, what is the other way of doing it? Other way of doing it is simple logic. If I look at this point, at point A, remember, one way that works for one question, it may be difficult for the other one because maths will come in between and you might not be able to calculate this thing. So you must know if there is another way which is simpler, probably you should know this. If you look at the point A only has horizontal velocity. And the horizontal velocity at point A is v. But as you go from point A towards point B, the horizontal velocity becomes from v slowly becomes 0 at the highest point. Yes or no?
So,
Velocity from B as you go up becomes 0 as you go up on the top. Yes or no?
yes, sir.
This velocity should vary constantly. That means the horizontal velocity of the center of mass in the horizontal direction, which is at a distance L by 2, would be how much? The horizontal velocity of this point should be how much? It should be v by 2. Now, if you look at the vertical velocity at the highest point is v by tan theta. And at the lowest point, it is 0. So what will be the vertical velocity at the center? It would be v by 2 tan theta.
Yes, sir.
This is the easiest way to find it out. Do you understand this?
Sir.
This is the easiest way to find it out, probably.
Sir,
Yes?
could you please again say how did v by 2 tan theta came?
Do you understand how this v by 2 came?
Yes, sir, we got that one.
If you understand how this v by 2 come, understand this how v by 2 tan theta comes. Do we understand this?
Sir, once say it again, sir.
Which part you did not understand? The pink one or the green one?
Green one.
How did I get the pink one?
Uh,
How did I get the pink one? You understand the pink one, no? Yes or no?
mm,
The lowest point, the velocity is v. At the highest point, the velocity is 0. So what is the velocity at the middle point? At the highest point, the velocity is v by tan theta. At the lowest point, the vertical velocity is 0. So what is the velocity at the middle point? This is common sense.
yes, sir. We got it.
Middle point, the velocity has to be half. Once you get this velocity, you can write this velocity of center of mass in the form of vector. And now you can write in the form of vector. It will be v by 2i plus v by 2 tan theta j. Do we understand this? Do we understand this?
Yes, sir.
Pakka?
Yes, sir.
V by 2 divided by V by 2 tan theta. I mean, V by 2 is the x component and V by 2 tan theta is the y component. Then, do we understand this?
Yes, sir.
Everyone?
Everyone.
Once you understand this, and you also know the value of omega, and you know the velocity of center of mass, you can calculate the kinetic energy of this rod. Yes or no?
Yes, sir.
Half I omega square plus half mv square. Anyone understands this?
Yes, sir.
Pakka?
Yes, sir.
Okay. Now you can also find out actually the angle that this velocity makes with the x-axis. So if I call this angle as phi, you can find this angle phi. Tan of this phi. How much will be tan of this phi? It will be perpendicular divided by base. Yes or no? Or let us not call this angle as phi. Let me call, oops. Let me call, this is the velocity v dash of center of mass. Do we understand this? No, it has two components, one along x-axis and one along y-axis. Yes or no? If I call this angle as phi, why I'm writing it as theta? If I call this angle as phi, remember this tan of phi will be your v by 2 divided by v by 2 tan theta. And you will see that this phi becomes equal to theta. And that is an important result that I wanted to tell you. So this angle phi actually comes equal to theta. This is phi. Do we understand what I am saying?
Yes, sir.
So the center of mass has a velocity which makes the same angle theta with the vertical that the rod makes with the horizontal. Are you getting my point? So remember this small result. If it comes anywhere and it will only come in a JEE Advanced, you should be able to find it out. Remember, the only things they are going to ask, and you know it, and you know it in your ways. I have just told you all the combinations, various permutation and combinations of this question that are possible. I will again repeat it. What is known to you is the velocity v of the point A. Sometimes the velocity A, point A is known, sometimes velocity B or point B is known. Whatever is known from velocity of point A, you can calculate the velocity of point B. From velocity of point B, you can calculate the velocity of point A. Yes or no? You can find out where the ICR is. You know the location L cos theta, L sin theta, depending on which theta is given. You can find out the angular velocity also. I have told you the way to find out the velocity of center of mass. From there, you can find out the kinetic energy. The other thing, what angle this velocity makes. So you must know that the velocity is v by 2 in the x-axis and v by 2 tan theta in the y-axis in this case. And the angle that this velocity makes with the y-axis is the same as the angle that the rod makes with the x-axis. Do we get this?
Yes.
So this is all that they can ask in this particular question. This was a question where the velocities were not their velocities were intersecting. I will give you one more case of here where you can also find it again. We have already done this case. I'm just going to show it again. So again, I take the example of this disk, or this ring. Now, as you know, if I say that the velocity of this point is 2v, and velocity of this point is root 2v, making an angle of 45. Can you tell me where is the instantaneous center of rotation? You can take the radius of this ring as r if you want to. It's a ring. Again, I'm asking you a question in a different fashion. We've already done this question. I'm just asking you in a different fashion. Nothing else. Yes?
Sir,
For what?
what we have to find, sir?
Yes, sir? Yes, beta?
What we have to find, sir?
Where is the center of rotation?
Center of tension.
Change.
It is at the point of contact, sir.
Center of rotation, and it is at the point of contact. This is again the case of which case? This is again the case of pure rolling. This is again the case of pure rolling, and your velocity. This is again the case of pure rolling. Do we understand this? I have done this question in so many different ways so that even if any one of these comes, I can be happy that I have told you that case. And remember, I remember everything that I've taught. And I'll show it to you that in this class, this lecture, this point, I said this. And I have the recordings as well of all the lecture that I'm taking. So I will show you the recording as well as a proof, visual proof, audio proof, every proof I will keep. So please remember, beta, please remember, whatever I have taught you in the class, nothing can come out of it. And I can say it with full conviction. 99% of the things will come from my topic. Only 1% JEE advanced, maybe one or two questions. Maybe I have not done the same question in the class. That's it. That's the only probability left. 1%. 1 to 2%. Somewhere there. Anyway, so I will wind down this class here. Do you understand pure rolling?
Yes, sir.
In the next class, if everything goes fine, we might probably move on to this pure rolling, which has been rolling since the last class. And it will keep on rolling in the next class as well. And remember, no one understands rotation. And I'm only concentrating again on that sort of problem which I think can come in the JEE. Because as I told you, I can keep on teaching you rotation for 2 years. Still, I will not be finished with the problems. There are so many problems that can be made. So take care. God bless you all, and Whatever I say it in a joking fashion, but I mean it seriously,
Yes.
because I know that you guys can do good. And if you don't remember simple things, I get angry. So try to remember them, because those same things I know beta can come and will come in your exam. Please
Sure.
remember them. Please remember them.
Thank you.
Okay. Take care. God bless all of you. Bye bye.
Thank you, sir.
Everyone understood what we done in the class today?
Yes, sir.
Pakka?
Yes, sir.
Okay.